Okay, great. Hi, everyone. My name is Sarvenaz, and I'm helping Professor Stickle with his research on active learning. This has been such a useful opportunity for me in particular because I'm also a tutor. So I'm interested in learning about alternative teaching practices that I can myself employ. The other thing about me is that I'm an adult student. So I share this because years ago, when I was in high school, I really struggled with subjects like math and science. What I realize now, looking back, is that I initially lacked a strong foundation in these courses. So I'm really appreciative of any part in engineering education research or educational research in general, because I think the underlying goal of it is to help to deepen students' understanding of their courses and to be more successful in their programs. So I think, I guess, looking at this, it already begs some questions for you. For example, what's active learning and what's metacognition? Active learning refers to engaging student-centric teaching techniques. So that could be flipped classroom, polling, think, pair, share, essentially anything which encourages students to interact with the material. Metacognition refers to a student's or anyone's awareness of their own knowledge and how to use it to complete tasks effectively. Our research or our review of the literature indicated that both of these concepts, here I'll zoom in here, are widely associated with a series of positive learning outcomes, including problem-solving skills. So I'm sure you're wondering, why are we looking at problem solving specifically? Well, that's because problem solving is very crucial to engineering professions. A 2015 journal article revealed that on average, employers in engineering occupations value a set of 12 workplace skills, including problem solving, above technical knowledge of science and math. An article that was published just last year in the International Journal of Advanced Corporate Learning, in it was also argued that engineering grads are still not sufficiently experienced in resolving complex problems. Now, with all that said, the literature still does not often elaborate on how active learning fosters problem solving, and that has motivated us to consider metacognition as the mechanism which links these two things together. More specifically, we want to look at the impact of active learning on students' development of metacognitive abilities and whether those abilities help students to effectively solve closed-ended technical problems. And that's what's summarized here in these research questions. In order to answer these questions, we've designed a research experiment. More specifically, we plan on holding virtual review sessions for first-year Civ 100 students in the fall. Students will be randomly assigned to an experiment or a control group. Students, or I guess all students, will be meeting on Zoom, but students in the experiment group will solve Civ 100 problems by way of active learning techniques, whereas the sessions for the control group will mimic a more traditional tutorial. Each of these sessions will be held 6 times throughout the semester. We're going to use surveys to collect data about student demographics, problem-solving confidence, active learning experiences and learning skills, and a series of other things which we think could influence their engagement with these review sessions. So essentially to control for them. We're going to assess students' problem-solving skills by requesting authorized access to students' grades on major Civ 100 assessments. Third, we're going to use think aloud assessments to assess students' metacognitive skills and processes. This entails having students solve Civ 100 problems with an examiner present while they verbalize their process. And we will record these to use for analysis at a later date. We're going to assess students' metacognitive skills using the framework you see in the top right corner. This conceptualization into metacognitive knowledge and metacognitive regulation is actually quite commonly invoked in literature. So we're going to assess students' metacognitive knowledge by assessing the accuracy of their understanding of relevant course concepts, and then on to assessing their metacognitive regulation by first classifying their problem-solving decisions under these categories, and then seeing the extent to which those decisions are intentional. Now, what I mean by that, for example, is a student can be solving a problem, and midway they could completely scrap what they're doing and revert to a different strategy. In one case, that could be because the student kept running into dead ends and wasn't sure what else to do, so they would try a different approach. But in another case, taking that first strategy helped the student to realize what they're doing wrong and how to resolve that issue. So in the second case, we would say that the decision was intentional. Now, I realize that there are ambiguous cases where it's not often clear what's intentional and what's not. And to be frank, we haven't really figured out exactly that element of our methodology. Although what we've seen done in literature is we've seen researchers use an agreement or consensus system to make these ambiguous judgments. I have our proposed experiment timeline here for your interest. We're hypothesizing that by solving these Civ 100 problems using active learning exercises, students are able to develop accurate metacognitive knowledge and intentional metacognitive regulation. Then in turn, we think that that will lead them to effectively or successfully be able to solve Civ 100 problems. One of the limitations we think of our research is obviously the generalizability to non-virtual contexts. We think for that reason, maybe the next step for us could be to integrate with a course and to implement this project in person on a larger scale when global circumstances permit. At this time, I think that we're optimistic that our findings could help the engineering education research or in wider community in general to be able to see the benefits of active learning on students' ability to succeed in the program implemented virtually. And then also we hope that maybe it would help the wider community to see, just by looking at our research and our final report, how they can facilitate interactive experiences online. That's it for my presentation. I would like to open the floor for questions, please.
Thank you, Sarvi.
My pleasure. Thank you. Oh, should I stop sharing my screen?
No, just keep it in case.
Okay,
yeah.
Yes, please keep it up.
Okay.
So the first question is from Professor Imami.
Oh, yes, thank you. I guess I, again, have room to ask only one question, and I asked the most important one. I'm not sure if I understood the relation between the experiment that you designed and the hypothesis which you would like to prove or disprove. Is the hypothesis about the causal relationship between problem-solving skills and metacognitive abilities? In other words, are you going to prove that by having active learning, you will be enhancing metacognitive knowledge and skills, therefore, and as a effect, you will be enhancing the problem-solving skills? If that is a causality that you want to prove or disprove, I'm not sure if that experiment will do it for you.
So we're not necessarily, I guess, invested in proving the causality. I think maybe the best we can hope for is proving or showing those relationships, the correlations between these variables. The reason we have metacognition come to play is because I think if we can uncover another variable that is connected to both active learning and problem-solving skills, it is a better argument for a potential causal relationship. And maybe this way we can better endorse active learning uses to instructors in education, in engineering programs. And this also goes back to a different discussion on faculty and students' perceptions of active learning being sometimes negative. So how do we better endorse active learning and our idea of that is to, in order to better endorse it, we have to better show how it works. So to go back to your question, we don't know that, I mean, we do know that this wouldn't, you're right, prove a causal relationship, but we think it would deconstruct the relationship a bit more.
Thank you, Sarvenaz. Very interesting work. I'd love to have a 5-hour discussion with you on this research work.
Oh, me too. Unfortunate that we can't. But when it eventually comes out, Professor Stickle, I'm sure, will do a final report and distribute that.
Thank you.
Okay, next question is from Professor D. Eliotrio.
Yes, thank you. Do I have my mic on? Yes, okay. Thank you very much, and I enjoyed your presentation, and I find all of these educationally directed research to be quite interesting. Your hypothesis. Let me begin with that. Your hypothesis almost sounds a little circular.
Yes.
Because you want to use you want to have solving problems. You want students to solve problems to gain a better appreciation of their metacognition, to be able to solve problems. Now, I presume that the type of problems that we're talking about at the front end and the back end are different. Is that the case?
Do you mind clarifying what you mean?
Yeah. Well, okay. So if I look at your hypothesis, you're saying solving problems using active learning exercises will lead to enhanced accuracy and appreciation of metacognitive knowledge, which will then lead to effective problem solving skills that can be used in, for example, the course that you're talking about, the Civ course. So it sounds a little circular to me. So unless you're talking about different problems or different AL exercises in the first part.
So I guess just to clarify, and I suppose this is due to a lack of great wording on my end, what we mean in the end is not only effective or not necessarily effective problem solving skills, but successful problem solving skills. So the ability to resolve the question, come up with the correct answer. And that's because in our data collection methodology, we don't have any mechanisms in place to be able to test to see if students are adhering to a certain problem solving framework or whatnot, but that they're getting the right answer in the end. So that's why we're referring to their grades on assessments. And then to go back to, I guess, problem solving as the independent, solving problems as the independent variable, it's true that perhaps there's a little bit of circulation here, although I would say that the emphasis isn't on problem-based learning. The emphasis is more on the activities that we're going to use, such as student response systems and discussions using features like breakout rooms, polling. It's more about the process of using those. Now, of course, I think we have to think more about how do we isolate the problem-solving element with the active learning element.
So the exercises would include things like discussion in breakout rooms, things like that?
Yeah, those are features we'll be using. And then the activities, we haven't decided completely yet which ones we're going to be using. So that's the stage we're at now, is developing the workshop models. Okay,
very well. Thank you. I look forward to hearing more about it.
So the last question is from the other judge, Maria. She asked, can you please briefly elaborate the gap in this project?
Yes, of course. So I guess the gap in this project is that active learning has been tied to problem-solving skills. Metacognition has been tied to problem-solving skills, but rarely in literature do you see the tie between metacognition and active learning. It's more editorials that we see elaborate on the potential helpfulness of active learning on students' ability to develop those skills, but not as much research. And so I guess that would be the gap. And then an additional, maybe supplementary gap is in the world, not maybe in research or literature, is students' ability to enter the workforce with an adequate preparation on their belts to have been adequately prepared to solve complex problems.
Thank you very much.